Muchísimas gracias a todos los que nos acompañan en esta última fase de CHEM. CHEM es nuestra Canadian Higher Education Mission, para quienes no estén familiarizados. Sé que tenemos invitados nuevos de instituciones aquí en México. Quiero agradecerles a todos por participar. El día de hoy tenemos como invitados a la Lakehead University, con Pierre Speth y el profesor de Guise, quienes nos van a platicar acerca de la oferta educativa que ellos tienen, y vamos a platicar un poquito acerca de físicas y matemáticas con el profesor de Guise. Entonces, Pierre, muchísimas gracias por participar otra vez. Esta sesión va a ser grabada y va a ser compartida en nuestras redes sociales. Y bueno, te cedo la palabra, Pierre. Muchísimas gracias.
No, pues muchas gracias a ti. Entonces, Lakehead University, somos una universidad en la provincia de Ontario, Canadá, con más de 8,500 estudiantes en total y unos 1,800 estudiantes internacionales que vienen de más de 60 países. Tenemos 86 programas, tanto de licenciatura como posgrados, y no todos nuestros programas están certificados por la universidad, por CONACYT, perdón, en México. Aquí viene el mapa de Canadá. Entonces les vamos a ver los dos campus que tenemos. El campus principal está en Thunder Bay, está aquí, y tenemos un campus pequeño que está en orillas, cerca del aeropuerto de Toronto. Thunder Bay, típicamente cuando llega a Toronto, tiene 15 conexiones para Thunder Bay, de Toronto a Thunder Bay, pero manejando es unos 17 horas, entonces es mejor tomar el avión. Estamos sobre el lago Superior, el lago más grande de agua dulce del mundo, y al norte de Thunder Bay tenemos un bosque boreal del tamaño de Francia, y estamos cerca de la frontera con Estados Unidos, con el estado de Minnesota. Ahí en Thunder Bay es donde se dan los programas de física y física matemática. Aquí les comparto algunas imágenes para que vean del campus de Thunder Bay. Tenemos todo en el campus, residencias, facilidades de última, muy modernos, y también estamos en plena naturaleza. El campus de Orilla está un poco más pequeño, pero también es más reciente, y ahí solamente por el momento se dan programas de licenciatura. Voy a pasar entonces, voy a presentar primero al doctor Hubert de Guise, porque estamos un poco apretados para el tiempo, y vamos a proceder en inglés ahora. So Dr. Hubert de Guise has a PhD in mathematical nuclear physics from the University of Toronto, and a 4-year postdoc degree at the Centre de Recherche Mathématique à l'Université de Montréal. He has an 8-month appointment at Faculté Saint-Jean, which is a French faculty at the University of Alberta from 2000 to 2001, and he was appointed as professor and researcher at Lakehead University in July 2001. His research focus is on application of symmetry methods in physics. He's also a frequent visitor to Mexico, especially Guadalajara. He's also visited the National Institute of Astrophysics, Optics, and Electronics in Puebla, and also the Physics Institute in Cuernavaca. He's adjunct professor in physics and astronomy at the University of Calgary. So I'm going to share my screen again and go back to our presentation. And I'll turn it over to Dr. de Guise.
Muchas gracias, Pierre. Disculpa, pero solo hablo muy poquitito español. So it is better if I continue in English, really. So thank you for your attention. I'm going to speak a bit about the Department of Physics. I wonder if you can see my background, because the picture in my background is actually taken in Thunder Bay as well. So it jibes with the theme that the city itself, yes. So this is taken in a park that is about, I don't know, 5 minutes. Not it's still within the city limits, but it's typical of the natural environment where the main campus in Thunder Bay is located. So now for some details about the Department of Physics. It's kind of a small department compared to other units. We have one faculty member in the Aurelia campus, Chris Murray. Chris, he works on the physics of environmental stuff, like how to get plastics out of the environment and this kind of thing. Up on the Thunder Bay campus, we have 5 regular. Ala Resnick, she's a Canada Research Chair, works mostly on detectors and applications to medicine. Mark Gallagher does surface science, nanostructures, and this kind of self-organized molecular deposition. Appy Linanenta does computational simulations of protein folding in this kind of computational biophysics. Dr. Gautam Das specializes in fiber optics and applications in particular to the detection of gases. And myself, I work mostly on applications of symmetries in quantum systems. Because we are such a small department, we have some adjunct professors, so people who are not regular faculty members, but still contribute to the program in one form or another. Maybe mention Peter McGee, who is the he's in charge of radiation therapy at the local hospital, so he's a professional medical physicist. Pat Rapley is also a medical physicist. We have right now, for instance, somebody else from the University of Saskatchewan who is collaborating with Ala Resnick, and we have some people from we have 1 or 2 members from chemistry as well. So they are technically speaking outside of the department, but they still manage to contribute through courses or student supervision or things of this particular sort. So as we now go to the next slide, certainly I mean, even though the Department of Physics is rather small, and we're going to come back to this, we still offer quite a good range of degrees. The basic backbone is the HBSC, so Honors Bachelor's in Science in Physics. And this is for the people who are, the students who are interested in a good mix of experimental and theoretical courses. So you see here, as illustrated on the slide, on the bottom right, this is an optical table in an optics lab. And towards a more top center here, this is actually a hologram. So if you know what's a hologram, it's a 3D picture. So the kind of reddish thing is the actual hologram there. And it's actually, the picture is taken through a holographic plate, and it's a 3D picture. I'm not sure if you can quite see, but on the right of the apparatus, there's a little, on the optics table towards right and down, there's actually a very small thing. It's actually a cow, a black and white cow. So it was arranged to actually take a hologram of this, and what you see in this kind of red glow is basically the 3D picture of that cow. This is representative of a typical upper level year lab in the HBSC in physics. We of course have other labs as well. And we also offered next as given on the next slide, we also offered a number of related affiliated degrees. So there's an HBSC in mathematical physics where some of the more experimental courses are traded for some math courses. We also have an important HBSc with concentration in biomedical physics. So this attracts students who are more interested in the biomedical aspect of physics, the physics of detectors that you use, for instance, at hospitals. If you have interested in radiation physics and that sort of stuff, that's the one for you. And we also have an honors degree that is concurrent with a Bachelor of Education that is geared towards the students who are more interested into, say, an education career, who would like to become a teacher or something of the sort. So on top of this, we also have degrees that are not honors degree, they're just bachelors of science in a variety of discipline. And I mean, not everybody necessarily is interested in doing 4 years of physics, and some of them, for instance, are perfectly happy to do BSc concurrent with a degree in education, which gives them the opportunity to teach at the primary or junior level. So moving on now, I did mention that one of our strengths, well, at least it's a small department. And so one of our strengths is the fact that we have pretty small class sizes. So in first year, it's a common year for everybody. The classes tend to be larger, and a large class will be 80. But as soon as you enter year 2, and then in year 3, and then in year 4, you rarely have classes that are more than 10, 12, 15 at the most. 15 is considered to be a sizable class in our for physics students in year 2 and beyond. There's still the odd classes that have a little more have a greater enrollment. Those tend to be classes that are shared with other departments, but by and large, the physics classes are fairly small. It's really good. The students get to know one another very rapidly. They make friends very rapidly. It's easy to have access to the instructor. Certainly for us and for many departments, there is a kind of implicit open door policy. You can just, you just knock on the door and people are always there, and they're usually pretty eager to help. The fact that we are a smaller institution is also good for research. Lakehead ranks very well in research for a primary undergraduate institution. And this is because, of course, because we do not have access to a large number of graduate students, we depend disproportionately on the expertise and the efforts of undergraduate students for our research endeavors. So lots of research opportunity for those who are quite interested to actually do real research and publish in peer-reviewed papers. It's also very, very hands-on. You saw this picture on the fourth-year lab there of the kind of instrument that students play with. There's a variety of other labs as well where it compares essentially with anything. So why should you study physics? Well, it's actually like a pretty decent outcome. So here I pulled out statistics, the latest ones I could find. This is from AIP, the American Institute of Physics. It's applicable to the United States, but it translates reasonably well to Canada. So this is from 2016, and it gives salary ranges for people who have graduated with different kinds of degrees, and you can see that physics is kind of way up there. What is interesting in this is that, of course, it's not a survey of all professional activities, but at least in this specific survey, the one above is aerospace engineering, and I can't tell you much about that. But the one above that is computer science, and I do have quite a bit to actually tell you about this, because you may have heard of quantum computing. So as you can see on the next slide, there's a revolution that is going on right now. something called quantum information and quantum computing, where the newer models of computers actually work on principles that that we see in quantum mechanics. So that quantum mechanics is this theory that explains the behavior of things on a very small scale, on an atomic scale. And so on the left here is actually a picture of the IBM machine, and on the right you can see what size it has. This one is based on superconducting squids. There are other designs. This one is freely accessible. If you can sort of play with it through an online interface. But you know, this is not the future. This is now. And in fact, we have 2 students from our program, Olivia and Dylan, who are actually now working for a company in Toronto, Xanadu.ai, where they are constructing a quantum computer that is based not on this particular design, but more an optical version of this. So we have had some good success in this particular way in some of our students getting high-tech job. They did move on after the undergraduate degree, but nevertheless, they are really at the forefront and at the cutting edge of what's going on in physics now. And of course, this merges quantum physics and computer science, which were 2 of the 3 of the top-ranked entries in that table there. Maybe you've also heard, as seen on the next slide, maybe you also heard of quantum teleportation, which is another aspect here where what you can teleport is actually information. This is a scheme that was cooked up by some Canadians as well and others. But one of the pioneers is a guy from the University of Montreal, Gilles Brassard. So I have a few slides to tell you a little more about my own research, which deals with symmetries and properties of quantum systems. So I've done quite a bit of work here just to show you, again, the involvement of students. So these nice pictures were actually generated from a computer code that was written by a previous student of mine, Ryan, who is now, by the way, he's actually, he runs a company that does vertical farming. So physics will take you to some unforeseen places. So this is a picture of, well, these are 4 pictures. It starts at the center and then it would run counterclockwise. The second one is bottom right. Then the third one is top right. And the second one is center top. And it shows the way in which a specific deformation of a quantum state evolves as a function of the deformation here. So you get these kind of nice shapes. And this is again, nice work done by a student. This was eventually published. I'm also quite involved, as you can see from the nice from the next slides. I'm also quite involved in the mathematics of interferometry. And what you see here, so what is an interferometer? You shoot light at one end and light comes out at the other end. So on top here, this is a chip for an experiment that was done in Vienna. So that's figure A, the size of the chip. So it's about, you know, it's slightly bigger than a pack of cigarettes, maybe thinner, but it's about more or less the size of a pack of cigarette. And at the bottom at part B, you can see when you shoot light through it, the light disperses through the network. And my job as a theorist was to understand the way in which the light would come out at the end. We have so we have a nice landscape there in the middle, and on the right, experimental results. So my job was to produce the landscape, and the experimentalists, you see, they found they picked 7 points of that landscape. They're illustrated by the pins, and there's pretty good, actually. There's pretty good agreement between theory and experiment. So maybe a little bit about my collaborators on the next slide. Pierre mentioned that I do quite a bit of, I go to Guadalajara quite a bit. So my main collaborator there is Professor Andrei Klimov at UDG. He has sent student over. So on the left, sorry, on the right, you see a picture of Ruben Arellano Cordoba. He was a student of Andre. He came to visit, and he's the left guy on the picture, and the right guy on that right picture is David Amaro Alcala, as just graduated from UNAM, and he's now started his PhD at the University of Calgary. And that picture was taken kind of across at a place called the Thunder Bay Lookout, so which is sort of nearby, that we had a chance to actually visit. So I'm nearing the end here. Feel free to email me, of course, if you have additional questions and whatnot. And I think that's about it. So eso todo para mí, Pierre.
Okay, thank you very much. And this is just to give students in Mexico and in Baja California just an idea of one of our programs that we have at Lakehead University, physics and math. And as you can see, it opens up a lot of possibilities for research, for jobs, for innovation. So any students that are interested in that field of study, I would highly encourage it as well. So we didn't give much general information on our other programs. We have over 57, but this afternoon, this evening, my colleague who's also on the call now, Hector Michelana, will give a full overview of Lakehead University. So thank you very much. I don't know, Roberto, if there are any questions, or I know we had a strict time limit, and Dr. De Gies, I really appreciate him. He'll be back on this afternoon, but I know he has a busy schedule and he has to leave for classes, but I really appreciate him taking that time to speak to the students today.
Yes, sure, Pierre. Thank you very much, Dr. De Gies, for participating and for your talk about physics and maths. Muchas gracias a todos. To our students, I don't know if you have any questions, comments. We will have Dr. De Gies at 3 o'clock Mexico time. Not yet, let me check on the chat. Have a great day, Dr. De Gies. Bueno, nuestros estudiantes, muchas gracias por haber participado en esa plática con el Dr. De Gies. Lakehead University, una gran opción para una universidad enfocada en research. Pierre, no sé si en ese momento ahorita no tenemos preguntas, pero no sé si tú quieres agregar algo más.
No, por el momento yo creo que es todo. Como les mencionaba, vamos a ir más en detalle sobre Lakehead en la noche con Héctor. Pero cabe mencionar que estamos muy enfocados en todo lo que es el éxito de los estudiantes. Entonces, Dr. De Gies mencionó clases pequeñas. Eso es una constante en nuestros otros programas. Y también, bueno, tenemos una red de apoyo, un centro para estudiantes internacionales. Organizamos actividades, talleres, hay tutores. Entonces, todo para asegurarnos que los estudiantes que se unan a nuestra familia tengan éxito en sus estudios y también en sus carreras profesionales.
Perfecto, Pierre. Pues muchas gracias por participar en esta primera sesión del día de hoy con Lakehead University.
Gracias, Pierre.
Gracias, nos vemos en la tarde entonces.
Perfecto, que tengas buen día.
Hasta luego.
Un rato.
Gracias.
Bye.